Welcome back. This is Mr. Greenstein's Geometry. We're in Chapter 3, Section 5. We're going to talk about equations of parallel and perpendicular lines. So first we're going to talk about a directed line segment. And that just means that it's a segment in which we're moving from one endpoint to another endpoint. In this case, we're moving from point A to point B of the segment AB. Now, if I wanted to determine along that path where it is, if I wanted to divide this into a 3 to 2 proportion, then what I'm going to do is I'm going to say that 3 to 2, the total equals 5. So I want to go 3/5 in the direction of the x and in the y. So what I'll do is I will take the direction of the x, which is the run, and it's going from 3 to 6, so that's going to be 3 units. So I take 3 units times 3/5, and that's going to get me 9/5. Or another way of saying that is going to be 1 4/5. And that's what I'm going to add to 3 to get over. So then I'm going to go over 1 4/5. And that'll put me around there. That's my run. And then my rise, I'm going to take the point here. The rise goes from 2 up to 8. That's 6. So 6 units times 3/5. So that's going to get me 18/5. And that's the same thing as going up 3 3/5. So I'm going to add 3 3/5 to 2 and go up 1, 2, 3, and right around there. So the ending point is going to be right around here. And that's where P is going to be. So I'm going to end up going a run of 1.8 more in the x direction and a rise of 3.6 in the y direction. And that'll get me this new point P. The slope of a line, parallel lines, since they're parallel, they have the same slope. In addition, two vertical lines are also parallel. Even though they're undefined, parallel lines have the same slope. Perpendicular lines are when we have non-vertical lines, then the product of their slope is -1, or the negative reciprocal. In addition, horizontal and vertical lines are perpendicular to each other, even though vertical lines are undefined in slope. So let's determine which of the lines are parallel and which of the lines are perpendicular. When I'm looking at this, it's fairly clear just to say that line D is going to be it's going to be perpendicular to one or two of these lines, maybe all three, but we have to determine that. And we can also see that it's not going to be parallel to any of these lines, whereas these could be parallel. Let's just work out what line D is. The slope of line D is we take the 2 points. I'm going to take this point first and then this point second. So if I take that point first, I'm going to say that the y is 2 minus 0 over -3 minus a -2. And when I work that out, I get 2 over -3 minus -2, which is +2, is a -1. So the result is a -2 slope. Let's just look at line B. The slope of B is going to be, well, I'm going to take this point first, and I'll take this point first, 2, 0, and I'll take 0, -1 second. So it's going to be a y of 0 minus a -1 over 2 minus 0, and that's going to be exactly 1/2. And 1/2 is the negative reciprocal of -2, or if we multiply them together, we get -1. So these are perpendicular lines. We're going to find that there's another perpendicular line, and I'll leave that for you to figure out. And there's also a parallel line, and I'll leave that for you to figure out. Now let's write equations for parallel and perpendicular lines. Write an equation of the line passing through the point -1, 1. So -1, 1 is going to be right here, parallel to the line of this equation. So -3 is going to be the intercept, and then it's going to go up 2 as its slope. And that line is going to be something like, well, when y is equal to 0, it's going to be 2. It's going to pass through this. So it's going to look kind of like this in the line. And we want to write an equation that passes through this point that's going to be parallel. Well, the thing that's most important is the slope, and their slope is going to have to be the same. So we're going to use the slope, the point slope form, y minus 1, which is what I get from here, is equal to 2 times x minus, and this will be this value here, a -1, which makes this a +1. So this is the equation for the line that passes through the point -1, 1 as parallel to this line. Now let's write an equation of the line that passes through 2, 3 that's perpendicular to this line. Well, this is not the form that I want, so I'm going to subtract 2x from both sides, and I'm going to get y equals -2x plus 2. And right away we can see that we have a -2 slope. So let's write something that has a perpendicular slope. So the slope that we're going to want is going to be perpendicular to this, which is going to be 1/2. So I'm going to use 3, so y minus 3 is equal to 1/2 x minus, and we'll use the other point 2, or the other coordinate 2. And this is the equation that passes through the point 2, 3 that is perpendicular to that line. Now let's find the distance from the point 1, 0 to the line. And this is going to be a little bit trickier, because what we need to do is we need to find the point that intersects. So if I have 1, 0, 1, 0 is right here, and then I have this line, it's going to be passing through at 1, 2, 3, and then it's going to be going -1 like this. So I have to find a perpendicular, and the perpendicular happens to be right at this point of 2, 1. So the distance I want to find is from 1, 0 to 2, 1. And the way that we do that is use the distance formula. So the square root of 2 minus 1 squared plus 0 minus 1 squared. And that equals the square root of 2. So that's the distance from the point to the line. It's not always so easy finding the distance, because sometimes we don't know exactly where that point that we want to defined as perpendicular. So we might have to do a little bit of work. This is going to be a slope of 1. You can see there's a 1 slope. So we want to use a -1 slope and this point to create the other line. So we're going to have y minus 4 equals -1 x minus 6. And then you use these two equations to come up with what the intersecting point is, and then that point is what you're going to use for your distance formula. And I'll let you work out the rest of the details. We'll discuss the rest of this in the next period.